We've been looking at positive fractions, but fractions can be negative as well. So this section on signed fractions, let's include the negative guys. So yeah, a good way to see what's happening is to look on the number line. Yeah, so we've been using rectangles to represent fractions. Maybe, yeah, that's not so useful for negative fractions. So let's put them on the number line. In this example, let's plot these five fractions. All right, so three quarters. So where is 3/4? So that's a positive fraction. So that's to the right of 0. And 3/4, yeah, so here's 1, so that's 4/4, 4/4. For 3/4, yeah, that's here. So just dividing the length between 0 and 1 into 4 equal pieces. Yeah, so it's it's like having a rectangle here. So 1/4, 2/4, 3/4 is here. Negative 3/4, well, that's just you just go the same distance on the other side, so to the left of 0. So 1/4, 2/4, 3/4, negative 3/4 is here. Negative 4/4, so negative 4/4, that's negative 1. That's here. All right, so yeah, so just on the number line, it's easy. So you can see the symmetry. So 3/4 is here. If you reflect it through 0, you get negative 3/4 over here. How about this fraction, 0/3? Well, 0 over anything is just 0. So 0/3 is here. All right, so that one doesn't have a sign. It's just 0. And yeah, so I'm saying here that yeah, if you're looking at proper fractions, so fractions, well, positive proper fractions, proper means that the top number is less than the bottom number. All those proper fractions on the number line, they lie here between 0 and 1. Yeah, 1, any fraction that's equal to 1, that's not a proper fraction. So say 4/4, that would be improper. All right, so there's lots of fractions in here. But fractions, yeah, they can be improper. They can be 1 or more. And so 12/5, that's improper. The top is bigger than the bottom. So where does 12/5 go on the number line? So yeah, to see where it is, it's useful to convert it to a mixed number. So 5 goes into 12 2 times. That's the whole number part. Remainder 2. So that's this 2. Yeah, I should have used, say, 13 over 5, 2 and 3/5. But yes, the remainder goes here in the fraction part. So as a mixed number, 12 over 5 is 2 and 2/5. So now we can see where it is. So 1, 2, and add another 2/5. You get to here. So this time I'm dividing the interval from 2 to 3 into 5 equal pieces. So 1/5, 2/5. And the negative version, that's just, again, it's going to be the same thing, but on the negative side, so -1, -2, and another -2/5 gets you to here. All right, so this is negative 12 over 5. All right, so positive numbers, whole numbers, fractions to the right of 0, and negative guys to the left. And yeah, so just to be careful, yeah, these mixed numbers can get confusing. So yeah, this -12/5 as a mixed number, you write it like this, -2 and 2/5. But this minus, it really means everything here is negative. So it really means -2 minus 2/5. Yeah, we saw that up here. It's -2, and then you subtract the 2/5, so you're going left. The positive version, 2 and 2/5, that means 2 plus 2/5. So you're going right. All right, so yeah, mixed numbers, it's easy to make mistakes. All right, so how to simplify the sign of a fraction. Remember, fractions mean you're dividing the top number by the bottom number. Okay, so if the two numbers in your fraction have signs, then, well, if they have the same sign, so you're dividing two numbers with the same sign, then the answer is positive. So the whole fraction is positive. But if your fraction has two numbers with different signs, then the whole fraction is negative. You're dividing a positive by a negative or negative by a positive. The answer is negative. For example, a fraction like this, -3 over -7, well, we can think of this as -3 divided by -7. As division, these two numbers have the same sign. They're both negative, so that makes the answer positive. So it's plus 3, 3 divided by 7, so it's positive 3/7. All right, so yeah, any fractions like this with two negatives, that simplifies to a positive fraction. It's very easy to think that this is negative, but really those two negatives, dividing a negative by a negative, it's positive. For this fraction, we have a positive divided by a negative, so those are different signs, so the whole thing is negative. So negative 4/5. All right, so this negative 3 over negative 7, that number it simplifies to 3/7. So on the number line, it's positive. It's to the right of 0. So here's 3/7. This time I'm dividing into sevenths. Yeah, this is 1 here. And this guy, 4 over negative 5, yeah, we saw this whole thing is negative, so it's to the right, to the left of 0, 1/5, 2/5, 3/5, negative 4/5. All right, so just when you're working with fractions, you want to know, is the whole thing positive or negative? Example 2, simplify the signs of these fractions, deciding if they're positive or negative. All right, so this is easy. We have different signs. So this first guy is negative 2/3. Same sign, so this is positive 11/3. Yeah, what's happening on the bottom here? This means the opposite of negative 9, so that's really a 9 on the bottom. So yeah, this is simplifies to just 4 over 9, so that's positive. And this is a positive over a negative, different signs. So the whole thing is negative 1/13. So this is the main one where I see mistakes. Don't forget, a negative divided by a negative is positive, not negative. You never usually see negatives in the denominator. Yeah, usually when you're writing fractions, so if you have a negative fraction, you can write it like this, also like this. So we'll see this. This is also useful, making the top number negative. But yeah, don't forget these are really the same. So negative 2 over 3 is equal to negative quantity 2/3, 2 over 3. All right, so yeah, it's confusing. Okay, we'd like to be adding and subtracting fractions. Remember from section 2.3, yeah, when we were working with whole numbers, here's the rule to add two sign numbers. If the numbers have the same sign, so both positive or both negative, then you add the absolute values and keep the sign. So if you add two positives, it'll be positive. If you add two negatives, the answer will be negative. If you're adding two numbers with different signs, so one positive and one negative, then you subtract the absolute values and use the sign of the number with the larger absolute value. Okay, so we looked at this, lots of examples. I hope you remember. And yeah, we can use this rule when we're adding fractions as well. example 3, find negative 3/4 plus 2/3. Okay, so when we're adding fractions, yeah, we want to use this formula. We need so if we have a common denominator, then we can just add the tops together. Okay, our denominators here are 4 and 3. So if you look at the least common multiple of 4 and 3, you see it's 12. So the LCD, the least common denominator we can use, is 12. Okay, so what do I have to multiply the 4 by to get 12? Well, I need 3. So multiply top and bottom by 3. So negative 3/4 is equivalent to negative 9/12. Now here, yeah, it's useful to go from negative 9/12 to write that as negative 9 over 12. Okay, so we're going back to this this idea. Okay, so in our formula, we're going to put in negative 9 for A and 12 for C. Okay, we need 12s here, so multiply by 4. 4, so 2/3 is equivalent to 8 over 12. Okay, so it's like the B is 8 and the C is 12. All right, so writing it like this, we're getting negative 9 plus 8 on the top, everything over 12. All right, so I hope that makes sense. So it's just a common denominator, but now the difference is we have a signed fraction, and we're moving the sign to the numerator, to the top. Okay, so on the top, yeah, now we're adding sign numbers again. So we have negative 9 plus 8. We're adding two numbers with different signs. The absolute value of negative 9 is 9. The absolute value of 8 is 8. Yeah, they have different signs, so subtract the absolute values. So 9 minus 8 is 1. And use the sign of the number with the larger absolute value. So this negative number, negative 9, has the bigger absolute value, so we need the negative sign. Negative 1. Okay, so negative 9 plus 8 is negative 1. So we have a negative 1 on top, negative 1 over 12, and then simplify this to, yeah, we have a negative over a positive, so the whole thing is negative. Okay, so yeah, this is correct, but yeah, maybe this is the best answer. So we see that the answer is a negative number, negative 12, negative 1/12. All right, so those are the steps we need. Again, when you're adding fractions, yeah, whatever their signs, you always need a common denominator. Ideally, the least common denominator. That was 12 here. So we just rewrote the first one as negative 9 over 12. The second one is 8 over 12. And on the top, we ended up with negative 9 plus 8. And just doing that carefully, that's negative 1. So negative 1/12. All right. Okay, how about with mixed numbers? So yeah, there's no really good way to do this. Well, first of all, yeah, we're the operation here is subtraction. So you remember from chapter 1, any subtraction question, you can write it as an addition question, addition of the opposite. All right, so this number minus 7 1/3 as an addition question, yes, keep this, change this to addition, change this to the opposite. It's 4 3/5 plus negative 7 1/3. All right, so keep, change. It's just, yeah, we always want to be adding. Okay, now we can see maybe more clearly what we're adding. So yeah, 4 3/5, that's a mixed number, but it really means 4 plus 3/5. Here we have a negative mixed number, so that really means negative 7 minus 1/3. Or if you like, negative 7 plus negative 1/3. Okay, so just kind of expanding everything out, we have, so this sum here, if you kind of break it into pieces, it's 4 plus 3/5 plus negative 7 plus negative 1/3. All right, so yeah, why are we breaking it up like this? Well, kind of the nice idea is we can, we saw this in the last section, we can add the whole numbers and then we can add the fractions, so doing those two parts separately. All right, so we're kind of taking it out of order, but that's okay if you're just adding. Addition is commutative, so I can switch these two. So 4 plus negative 7. Okay, so back to adding sign numbers. Different signs, subtract the magnitudes. Use the sign of the bigger number, which is negative, so negative 3. Next, add the fraction pieces. So we have 3/5 plus negative 1/3. The LCD is 15 here, so put everything over 15. That's 9 over 15 plus negative 5 over 15. Okay, so, and then, yeah, this whole thing is negative. I'm writing the top numbers in negative. And so it's 9 plus negative 5 over 15. Yeah, that's 9 minus 5. So that's 4 over 15. Okay, so from the whole number pieces, we got negative 3. From the fractions, we got this. So we're adding these two together. So far we have negative 3 plus 4 over 15. Okay, and then the last step is, yeah, we want to combine these into a single fraction or a single mixed number. Yeah, this, just to be careful, so this whole thing is not equal to negative 3 and 4/15. Yeah, I can't just put them together because negative 3 and 4/15 really means negative 3 minus 4/15, like we saw up here. So how can we combine these? Well, yeah, one way is just to add the fractions. So think of negative 3 as negative 3 over 1. So the common denominator is 15. So this becomes negative 45 over 15 plus 4 over 15. Um, add those two sign numbers, you get negative 41 over 15. So this whole thing is negative, negative 41 over 15. So that's a good answer. You can also convert this to a mixed number. 15 goes into 41 two times. That's 30, so remainder 11. Okay, so as a mixed number, it's negative 2 and 11/15. Oh, yeah. Maybe easier, yeah, using the borrowing idea we used last time. So, yeah, this negative 3, you can write it as negative 2 minus 1. And that negative 1 is negative 15 over 15. And then if you add these two together, you get negative 11 over 15. And now this is a good mixed number. This is negative 2 and 11/15. All right, so yeah, these. So like I said, there's no really good way to add mixed numbers. I hope you followed those steps. I mean, maybe an easier way with less steps but bigger numbers is you could convert these to improper fractions in the first step. So this is so 4 times 5 plus 3. This is 23 over 5. Minus 7 times 3 is 21, plus 1 is 22 over 3. Okay, then the LCD is 15, so then multiply this by 3. Multiply this by 5s. Okay, so yeah, the reason I'm kind of avoiding this down here is, yeah, you just get very big numbers. So what is this? So 69 over 15 minus 110 over 15. But you can do it this way. So yeah, 110 minus 69, that'll give you 41, and then with a minus sign. So that's maybe an easier way to do this type of question. Convert them to improper fractions first. Then yeah, you don't have to worry about sort of recombining the whole numbers into fractions at the end. And yes, we did see here, yeah, it's for our final answer, we converted this negative 41 over 15 into negative quantity 41 over 15. So again, yeah, we're often rewriting fractions that look like this. So simplifying them to get the sign of the whole fraction, or sometimes we're going this way, putting the sign up with the top number. All right, so at least multiplying or dividing two sign fractions or two sign mixed numbers, that is easier. You just need to remember the rule. if you're multiplying or dividing two numbers with the same sign, the answer is positive. Multiplying or dividing two numbers with different signs, the answer is negative. And yes, so for this, as we saw, so for multiplying or dividing mixed numbers, yeah, you do have to convert them to improper fractions first. Okay, so maybe some examples from the book. All right, so here's a product of two fractions. The second fraction is negative. All right, so we have we're multiplying two fractions with different signs. So the answer is, we can see right away the answer is negative. Okay, and then do the multiplication. So 3 over 4 times 6 over 5. Remember, you're multiplying straight across, so you'll get 18 over 20. But yeah, you can pre-cancel here. So this 2 out of the 6 cancels the 2 out of the 4 down here. So you can make your life easier. So when you cancel those 2's, you're left with a 3 here and a 2 here. So you get 9 over 10. So the answer is negative 9 over 10. It's maybe it looks a little bit like you're subtracting here, but no, it's you're multiplying. Even without that little dot, it means multiplication. Yeah, there's no dot here, just parentheses, but when you put two numbers together like this, it means multiply. These two numbers have the same sign, so the answer is positive. Okay, 2 1/2 as an improper fraction, that's 5 over 2. So 2 times 2 plus 1. Here we have 3 times 4 plus 1, that's 13 over 4. Multiplying fractions, so going straight across, yeah, there's no cancellation possible here. So it's just 5 times 13 is 65. 2 times 4 is 8. So 65 over 8. That's a good answer. And yeah, you don't have to do this step, but it's you can convert it to a mixed number. 8 goes into 65. 8 times remainder 1, so 8 and 1/8. Yeah, this is an easy one. So we have this negative improper fraction. So if you convert that to a mixed number, 5 goes into 33 6 times, remainder 3. So we get this negative mixed number, negative 6 3/5. Also division. Okay, dividing two numbers with the same sign, the answer is positive. Okay, also we want to convert this mixed number to an improper fraction. 2 times 9 plus 5 is 23. Yeah, so here, I know the answer is positive, so you can ignore the sign. So it's 23 over 9. We have 1/6 here. So remember how to divide fractions. You keep change flip. Okay, so dividing by a fraction is the same as multiplying by its reciprocal. The reciprocal of 1/6, flip it over, you get 6 over 1. All right, so it's we have 23 over 9 times 6 over 1. Pre-canceling some 3's here. So you get, so when you cancel 3's, you're left with a 2 here and a 3 here. So 23 times 2 is 46. 3 times 1 is 3. All right, yeah, so all these steps that they're adding up. So the first step here again was just to see that a negative divided by a negative is positive, so the answer is positive. So you can ignore the signs after you figured that out. Next step, we need to convert any mixed numbers to improper fractions. So this becomes 23 over 9. And then we do the operation. So dividing by 1/6 is the same as multiplying by 6 over 1, the reciprocal. Then I pre-canceled and then finally did the multiplication to get 46 over 3. And yeah, I'll just leave it like that. It's improper. And here's an addition, so adding a bunch of fractions, mixed numbers, positive and negative. A nice way to do it is to kind of separate the positives and the negatives, and do the positives first, and then add the negatives separately. Yeah, here the numbers are not too big, so yeah, we can convert everything to improper fractions. So 5 over 2 plus 2 over 3 plus 4 over 5, that's the positive piece. Okay, so if you do this first, yeah, the LCD here is 30, so you want everything over 30. So multiply this with 15s, this with 10s, this with 6s, and you'll get 119 over 30. And then adding the negatives together, so doing that separately, we get this. And then finally subtract those negatives. We need another common denominator, that's 60. Okay, so yeah, it's a lot of work doing these kinds of questions by hand. Okay, one last one. Here we have the power of a negative fraction. Actually, 3 different powers of this negative 2/3. Yes, so if you have an odd power of a negative number, then the answer will be negative. So negative times a negative times a negative. Negative times a negative is positive. Positive times a negative is negative. And so the answer is negative. And then it's 2/3 times 2/3 times 2/3. Multiply straight across to get 8 over 27. So negative 8 over 27. Yeah, here we just have the second power, so that's an even power of a negative number is positive. 2 times 2 is 4, 3 times 3 is 9. And then an easy one, so any number to the power 0 is always 1. Except, of course, the exception, 0 to the power 0 is undefined, but anything else to the power 0 is 1. All right, and then, yeah, so I think this is the last section in the chapter 3, so just to put everything together, so combine all the operations we looked at. And so yeah, we have to use our order of operations. Yeah, we saw this for whole numbers. PEMDAS, right? But like this. So yeah, P, do anything inside parentheses or grouping symbols first. E, exponents and roots, take care of those next. MD, let's put them together. So all the multiplications and divisions you do next, working from left to right. So sometimes you do dividing before multiplying if the division's on the left. And only when you've taken care of all of those, you do the additions and subtractions at the last step. AS together, so again, working from left to right, so sometimes you're subtracting before adding if it's on the left. Okay, example 5, find 2/5 plus 3/5 times 10/7. Okay, two operations, addition and multiplication. So yeah, we have to do that multiplication before the addition. So we're doing the M first. 3/5 times 10/7. Multiply straight across, you get 30 over 35, but better to pre-cancel. So yeah, we can see 10 is 5 times 2, so these 5s are going to cancel. And we're just left with 3 times 2 on top and 7 on the bottom. Okay, so you get the same thing if you with 30 over 35, but then you'd have to cancel 5s, see that they have greatest common factor of 5 and cancel it. Better to cancel before you do the multiplication. Okay, so this piece is, we've just worked it out to be 6/7. Now we do the addition, so the addition comes last. 2/5 plus 6/7. LCD is 35, so that's 14 over 35 plus 30 over 35 is 44 over 35. And looking to simplify it, yeah, I don't see any common factors to cancel. So that's the answer. And yeah, you could convert that to a mixed number, but since it's improper, but you don't have to, unless they ask you, right? But 44 over 35 is fine. Okay, this looks like a tough example. Example 6. What is this? All right, so we can see. Let's take a look at all the operations. Yeah, we have a subtraction here. We have a division here. This is not a subtraction. This just means the whole thing is negative. But we have a exponent here, and also we have parentheses here. Okay, so these parentheses are telling us that we do this subtraction first. Okay, so you have to Um, this is a grouping symbol, so we'll take care of this group first, the subtraction. So we're doing the p first, like we're supposed to. So -1/4 minus 3/8. That's the same as -1/4 plus the opposite of 3/8. Okay, so we're changing the subtraction to an addition. That's we always do it like that. We need a common denominator. It's the LCD here is 8. So make this -2/8 plus, keep this the same, -3/8. And then add those two. So it's -2 plus -3 on top. And so adding two numbers with the same sign, add the absolute values, keep the sign. So that's 5 with a negative sign. Okay, so this piece in parentheses is really, we worked it out to be -5/8. Okay, again, we're that -5 on the top, it's a negative over a positive, so that makes this whole thing, this whole fraction is negative, like we saw before. All right, what do we do next? Do we do the division next, or do we take care of this exponent? Yeah, so exponents come next, right? Then we'll do the division last. Okay, so we need this mixed number squared. Okay, so it's, yeah, right away I know it's a negative number to an even power. The whole thing will be positive. So we can ignore the signs, but this mixed number, it's 3 times 2 plus 1, that's 7/2. Yeah, so multiplying mixed numbers, yeah, convert them to improper fractions first. So it's 7/2 times 7/2, that's 49/4. All right, so this piece turned into 49/4, a positive number. And then the last step, take care of that division. We're dividing two numbers with different signs, so the answer is negative. And we're dividing by this fraction, so keep, change, flip. So dividing by this is the same as multiplying by the reciprocal, 4/49. Okay, I can see this 8 is 4 times 2, so you can cancel 4s. You're left with a 2 and a 1. Okay, so pre-canceling here, and we end up with 5/2 times 49 is 98, and the whole thing is negative. So -5/98. All right, that was a lot of work. All right, yeah, the main thing we're illustrating here is, yeah, the correct order of operations. So things in parentheses get taken care of first, then exponents, then any multiplications and divisions, and then if there were any extra additions or subtractions, they would happen last. And yeah, there's more examples in the book in this section. Yeah, so again, the order of operations, grouping symbols, exponents and roots, multiplication and division, and addition and subtraction last. So for this one, do you do the subtraction first or the addition first? So yeah, you do the subtraction first because it's on the left. Okay, so we're in this last case. Okay, so you'll do 2 minus 3/5 first. 2 is 2 over 1. The common denominator is 5, so 2 turns into 10 over 5. Minus 3 over 5, that's 7 over 5. And then do the addition. LCD is 10. So 19 over 10. Okay, so, but here, yeah, the parentheses here change the order of operation, so you have to do this addition first, take care of what's in the parentheses first. Okay, so working this out, it's 11 over 10, and then you do the subtraction at the end here to get negative 1/10. All right, and more examples here. There's an exponent, there's an addition, and there's a multiplication. So we'll take care of the exponent first. You get 4/9. Take care of the multiplication next. We need to convert this mixed number into an improper fraction. Multiply to get 5 over 30. And then do the addition. We need first simplify this 5 over 30, cancel 5s to get 1/6. Then the least common multiple of 9 and 6 is 18. So the LCD is 18. And we get the answer 11 over 18. All right, and yeah, so you can take a look at these extra examples. Yeah, this has 3 sets of parentheses. That looks nasty, but yeah, for kind of these nested parentheses, do the work on the inside parentheses first. So the first step here would be to work this out. So that would be the first step, and then work your way out. Yeah, this whole thing works out to 1 over 18. Okay, so then you get, so this everything in here is 1 over 18, and then you have to figure this out. So then you do inside these parentheses next, so 2 plus 1 over 18. And then finally you add that 1. All right, so that's combining all of our operations with mixed numbers, fractions, positive or negative. Yeah, you can certainly get some difficult questions, but I hope that made sense.